Today we're going to look at functions defined by integrals. So we're going to let f of x equal 2t minus 2 on the negative 2 to 4. So we're going to go ahead and graph negative 2 with a slope of 2 from negative 2 to 4. A of x is equal to the integral from 0 to x of this function. So we're looking at these different integrals. So a of 0 is going to be the integral from 0 to 0, which no matter what is always going to be 0. A of 1 is going to be the integral from 0 to 1. So we're looking at from 0 to 1. If we look at this geometrically, that's going to be the area of this triangle. It's below the x-axis, so it's going to be negative. So it's going to be negative 1/2 1 times 2, which is going to be a negative 1. Okay, a of 2. So now we're doing the integral from 0 to 2. Well, this area under the curve is going to equal this area above the curve. So that's going to be 0. For a of 3, we're going from 0 to 3. So from here to here is 2. But for this area, we're looking at this positive area. So this part's going to be 0. So I'm going to add that, which is going to be a trapezoid. So that's going to be 1/2 the height of that trapezoid is going to be 1. The two bases are going to be 2 and 4. So that's going to be 6 divided by 2 is 3. Going to negative 1. Okay, we're looking at the integral starting at 0, going to negative 1. So that's going to be this area here. So two things to consider here. The integral from 0 to negative 1 is going to be the opposite of the integral from negative 1 to 0. So if I were to just do the integral from negative 1 to 0, that would give me a negative value. But since I'm going from 0 to negative 1, that's going to give me a positive value. The other way to think about it is if you're doing the integral going backwards, and it's below the x-axis, it's going to be positive. If you're going backwards and it's above, it's going to be negative. So this is going to be positive, and then the area of this trapezoid is 1/2 1 2 plus 4 again. Okay, and then going back to negative 2, we're going from 0 to negative 2. So it's below the x-axis, but we're going backwards. So it's again positive. This trapezoid has a height of 2, and the two bases are 2 and 6. So this gives me 8. Okay, so where does this reach a minimum? Well, if I looked at the derivative of this integral, it's just going to be 2x plus 2. This is the graph of the derivative. So where is there a minimum value? Well, there's going to be a minimum when it goes from decreasing to increasing, which is going to occur right there at x equals 1. What happens as x goes to infinity? Well, these values, we were going from negative 1, 0, 3. It's just going to, and if we think about the area, it's just going to accumulate more area. So it's going to go to infinity. And then what happens to it as it goes to negative infinity? Well, I'm going backwards, adding the negative space, so that's also going to go to infinity. Okay, so now we're asked to graph this. So I'm going to graph the points that were given. So 0 was at 0, 1 was at negative 1, 2 was at 0, 3 was at 3, then negative 1 was also at 3, and then we were at 8. Okay, well that just looks like a parabola, right? So it looks like just a regular parabola, over 1, up 1, moved to the right 1 and down 1. So if I simplify this, we're going to have x squared minus 2x plus 1 and then minus 1. So now let's actually find our equation. So this is going to be t squared minus 2t evaluated from 0 to x. So that's going to be x squared minus 2x minus 0, which we came up with from the graph. Okay, let f of x equal the integral from 0 to x of f of x, where this is f. So find f of 0. So that means f of 0 is the integral from 0 to 0, which is 0. What value does f have an absolute maximum? So we're starting at 0, so it's going to be adding area to 2, then it's going to subtract area from past that. So the max is going to occur at x equals 2, because it's got the greatest positive area there. We can also say, since the derivative of capital F would be f, it's going from increasing to decreasing. Where does it have an absolute minimum? Well, it's always going to be at our endpoints or our critical points. So at 0, we're at 0. Then it's going to add positive area to 2, and then it's going to subtract area to 3. But since this area is less than this, we're still going to end on a positive value. So it's going to have a minimum at x equals 0, because f, capital F, of 0 is 0, and it will never go lower. Okay. All right, we got another one. This is the position of a particle is moving along the coordinate axis is the integral from 0 to t of f of x dx, where this is f of x. Okay, so what is the particle's velocity at time equals 3? Well, velocity is going to be the derivative of position, which is just going to be f of t. So we're just evaluating f of 3. So on this function, f of 3 is 0. Okay. Is the acceleration of the particle at t equals 3 positive or negative? So acceleration is the derivative of velocity, which is the derivative, in this case, of the graph we're seeing. So at 3, the graph is, the slope here is positive, so the acceleration is going to be positive. Okay, what is the particle's position at time 3? So our position equation. So we're going to have the integral from 0 to 3 of f of x. So that's going to be the area of this triangle, but negative. So this is going to be negative 1/2 3 times 6, which will be a negative 9. And then when does the particle pass through the origin? Okay, so we're going the integral from the position. So it's going to be negative, then it's going to increase. So at 6, it's going to start at 0, and then it's going to go negative, and then it's going to start moving back towards the origin. So at 6, this positive area and negative area cancel. So its position would be at 0. Approximately when is the acceleration 0? Well, that's going to be when the velocity's slope is 0, which means this graph has a slope of 0, which would be at t equals 7. When is the particle moving towards the origin? well, he's moving, starting here is 0, adding negative area till here, then changes direction and moves towards the origin. Okay, and then at 6, he's at the origin. Then it's going to add on more positive area, so it's going to be moving away from the origin. On which side of the origin does the particle lie at time t? So again, we're 0, then we add to negative, then we start moving towards the positive. At 6, we're at the origin, and then we're adding on more positive area, so this is going to be positive. All right, so here's a function on the closed interval 1 to 7. The h of x is the integral from 1 to x of f of t. So what is h of 1? So the integral from 1 to 1 is 0. H prime of 4 is going to equal f of 4, which is 2. On what intervals does the graph of h concave upwards? Well, the second derivative of h is going to equal the first derivative of f. So we're looking for where f is increasing, and that's going to be from 1 to 3 and from 6 to 7, because h double prime of x is greater than 0. And we arrived at that because the first derivatives would be increasing, which means the second derivative is positive. Find the value at which h has its minimum on the closed interval. So we need to check the endpoints and the critical points. So the endpoints is 1, the critical point would be 5, because that would be where the derivative is 0, which is f of t is 0, and 7. So at 1, our integral from 1 to 1 is 0. Then we're going to add on positive area until we get 5. So this is going to be a positive value, whatever it is. Then it's going to start to decrease because we're going to be adding on negative area. So it's still positive, but less than the value at 5. But it's not going to be not going to be 0. Greater than 0. So it's 0, it gets positive, then it starts to go down, but this area being less than this area means it's still going to be positive. So where does it have its minimum? At x equals 1, because it's 0 there and it's never 0 again. Right, let f be a continuous function where the graph is shown. Let h be the integral from -2 to x. Okay, find the zeros of h. So the first obvious answer is -2, because the integral from -2 to 2 is 0. Okay, so it's 0. Then it gets positive. We're adding on positive area, positive area, positive area to here. Then we start adding negative area, negative area, negative area. At this point, the area above the curve is going to equal the area below the curve. So at x equals 8 is going to be our second 0, because the positive area equals the negative area. Okay, on what interval is h increasing? That's going to be where the derivative is greater than 0. So we're looking for where f is greater than 0. So that's going to be For our graph here, we start at -4. Or we could just say from when x is less than to 3, because thinking about it, we're adding positive area, but more importantly, h prime of x, which equals f of x, is greater than 0. What is h of 0? So h of 0 is going to be the area. So it's the integral from -2 to 0. So it's going to be that area there. So that's going to be just 2 times 3, which is 6. Okay, for 0 is less than x is less than 6, we're going to express h in terms of x. So for specifically 0 to 6, the integral from -2 to x is going to be this area plus the amount that we're adding on dependent on where we are on this line. So it's going to be adding positive area here, subtracting area here, but it's really going to be adding on the integral from 0 to wherever from 0 to 6. So this is going to be 6 plus the integral from 0 to x of the equation for that line. So if you look above, the y-intercept of that line is 3 and its slope is -1. So we have -x plus 3. I guess this should be t. So this is going to be 6 plus -1/2 t squared plus 3t from 0 to x. So this is going to be 6 minus 1/2 x squared plus 3x, and if I plug in a 0 there, we get 0. So we have this, or we could rearrange it if you wanted to. Okay, let f be a continuous function defined from -3 or -4 to 3, whose graph consisting of 3 line segments and a semicircle at the origin is given above. Let the function given by g of x be the integral from 1 to x of f of t dt. So we're going to find the values of g of 2 and g of -2. So g of 2 is going to be the integral from 1 to 2 of f of t. So from 1 to 2, we're looking at that area there. So it's going to be a triangle. It's going to be negative. So it's going to be a -1/2 base times height. The base is going to be 1. The height, we're going down 1 over 2. So the height is going to be 1/2. So this is going to be a -1/4. G of -2 is going to be the integral from 1 to -2 of f of t dt. So there's going to be 2 ways to think about this. We're going from +1 to -2. So we're going to have this, and we're going to have this, but we're going backwards. So this area, even though it's below the x-axis, is going to be positive, and this, even though it's above, is going to be negative. Or you can think about it as being the opposite of the integral from -2 to 1, which would be this being positive, this being negative, but then the opposite. So the circle area, since we're going backwards, is going to be positive. So that's going to be 1/2 pi r squared. The triangle area is going to be negative. So 1/2, its base is 1, its height is 3. So this would be equal to pi over 2 minus 3/2. So then we're going to find g prime of negative 3 and g double prime of negative 3. Well, g prime of x is just going to equal f of x. So g prime of negative 3 is going to be f of negative 3, which on our graph is going to be this point here. So this is 3, that's going to be 2. G double prime of x is going to equal the first derivative of f. So the second derivative of negative 3 is going to equal f prime of negative 3. So the derivative here of negative 3 is a positive, the slope positive 1. So this will be positive 1. Okay, find the x-coordinate of each point at which the graph of g has a horizontal tangent line. For each of these points, determine whether g has a relative minimum, relative maximum, or neither. So we're looking for g prime of x, which equals f of x, to equal 0. Well, it equals 0 when x equals negative 1 and when x equals 1. At negative 1, f, which is the derivative, goes from positive to negative, which means we have a maximum. Because g prime of x goes from positive to negative. What about at 1? Well, it goes from negative to negative, so even though the slope there is 0, it goes from decreasing to decreasing, which makes it a plateau. So g prime of x does not change sign. Okay, and for the last one, for negative 3 to 4, find all values where g has a point of inflection. So the second derivative of g is going to be the first derivative of f. So we're looking for where f changes from increasing to decreasing or decreasing to increasing. So that's going to occur here at negative 2. It's going to occur here at 0. And it's going to occur here at x equals 1. Our justification, g double prime of x switches signs. Okay, and those are several examples of integral functions.